You know, when you talk to an AI like ChatGPT, it just feels like it gets you. But how? I promise you, it's not magic. It's actually this incredibly elegant piece of engineering. So today, we're going to pull back the curtain on the core idea that makes it all possible, something called the attention mechanism. I mean, come on, we've all done this, right? You type in some creative, kind of complicated prompt, and just seconds later, you get back a result that's, well, it's shockingly good. Sometimes it's even brilliant. That ability to understand what we want and then create with language, it feels incredibly human. So, what is really happening under the hood? How does a machine take a simple string of text and suddenly grasp context and nuance and all those complex relationships that actually give our words meaning? Let's dive in. Okay, so the very first step, before any of the real magic can happen, is basically translation. The AI has to convert our language, our words, into the only language it really speaks fluently: numbers. This all happens through a process called word embedding. Every single word, or token as it's called, gets fed into a neural network. And that network's job is to assign it a unique list of numbers, which we call a vector. Now, here's the really clever part. The exact same network is used for every word in the sentence. This design is what makes the whole system so incredibly efficient. So, now we've got numbers for all our words. Great. But this actually creates a huge problem. The meaning of a sentence depends almost entirely on word order. And right now, our AI has no idea what that is. Just how critical is this? Well, take a look. And yeah, this illustrates the point perfectly, doesn't it? Squatch eats pizza is a pretty happy situation. Pizza eats Squatch is, well, that's a horror movie. Same words, totally different meanings. So the model has to have a way to track the position of every single word. The solution is this really cool trick called positional encoding. You can think of it like a unique digital fingerprint for each spot in the sentence. By using this oscillating pattern of sine and cosine waves, the model generates a totally distinct signature for position 1, position 2, and so on. This signature then gets added to each word's vector. And just like that, the vector now represents not just the word's meaning, but its exact place in line. All right, now we get to the real heart of it. We have numbers that represent words, and we have numbers that represent their positions. But how does a model solve for ambiguity? How does it figure out that when you say the pizza was hot and it tasted great, the word it refers to the pizza, not the heat? For example, take the word bank. In this sentence here, it's totally ambiguous on its own. Does it mean a place you put money, or does it mean the side of a river? Without context from the words around it, the model simply has no way of knowing which one to pick. The answer is a really revolutionary idea called self-attention. Basically, the model lets every word in the sentence look at every other word to figure out which ones are most relevant for understanding its own meaning. It's almost like all the words in the sentence get into a little huddle to have a quick chat. So how does this conversation between words actually work? It all starts by creating 3 different vectors for every single word in our sentence: the query, the key, and the value. Let's break down what each one does. First up, you've got the query vector. This is our active word, the one that's looking for information. You can kind of picture it raising its hand and asking the rest of the sentence, "Hey everyone, given who you all are, what do you think I mean right now?" Next up, we have the key vector. Every word gets one of these, and it acts kind of like a label or a name tag. The query from our active word scans the key of every other word in the sentence, and it's looking for a match. It's looking for relevance. And finally, we have the value vector. Now, this vector has the good stuff, the actual substance, the real meaning of the word. Once the query and key have found a strong connection, it's the information from the value vector that gets passed along to help clarify things. And here is where it all just clicks into place. The query vector for our word bank compares itself to the key vector of every other word. For words like the and was, the score is pretty low. But when it checks the keys for river and flooded, ding, 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 we get a high score. The model has just figured out which words matter most. This scoring system, that's the key that unlocks absolutely everything. Those high attention scores are what the model uses to create a brand new, contextually aware version of our word. See, before this whole process, the vector for bank was fuzzy. It was ambiguous. It held the mathematical possibility of being both a financial institution and a river shore. It was just a mix of potential meanings. But after self-attention, poof, That ambiguity is gone. The model takes those high attention scores it calculated from River and Flooded and uses them to amplify the meaning, the value vectors of those words. This weighted meaning then gets blended back into the original bank vector, creating a new, refined vector that now points overwhelmingly to just one meaning: a river shore. So let's just do a quick recap of that journey for a single word. It all starts with word embedding, which turns the word into raw numbers. Then positional encoding comes in and gives those numbers a sense of order. And finally, self-attention, using that query, key, and value trio, lets all the words talk to each other to find their true meaning and context.
Look, this isn't just some cool technical milestone, it's a fundamental shift. We've actually built machines that don't just process words, they can grasp context. And as this technology gets woven deeper and deeper into our daily lives, it really brings up a critical question for all of us. When our tools understand the nuance of our language better than ever before, how does that change the very nature of how we communicate?